What's going on, everybody? Welcome back to another math lesson for today. In this video, I want to talk about how we can solve absolute value equations. And the thing about absolute value is it is defined as the following. So the absolute value of x is equal to x if the inside of the absolute value is positive. And we also have that the absolute value of x is equal to negative x if the event is that the x inside of the absolute value is negative. And the reason for that is if x is negative, the absolute value of that is going to be negative x, which just gives us a positive x. So this definition ensures that absolute value is always positive. So when we go to solve for absolute value equations, let's say we have x minus 5 is equal to 10, then we're actually going to be coming up with two equations. So the first one is for the event that the inside of the absolute value is already positive. So in which case, we go to x minus 5 is equal to 10. So that's easy. You just add 10 to both sides, or you add 5 to both sides, and you say x is equal to 15. And if I were to check this, I plug in 15 for x. So I have 15 minus 5 inside absolute value, which is absolute value of 10, which is just equal to 10. So this checks out. But the other equation that we have is in the event that the inside of the absolute value is negative, and we must add a negative sign in front. So you have x minus 5 is equal to 10. And if I divide through by a negative, I have x minus 5 is equal to negative 10 at this point. And then you just add 5 to both sides, and you have x is equal to negative 5. So if we have negative 5 inside of absolute values, when I plug it in, I get the absolute value of negative 10, which is also just 10. So this solution also checks out. But you can notice that we have a negative inside of the absolute value this time. So looking at another example of this, let's say that I had 2x plus 3 is equal to 7. So again, we're going to have two equations here. The first one is simple enough. We just have 2x plus 3 is equal to 7. So subtract 3 from both sides, and I have 2x is equal to 4. And then, of course, divide by 2, and you get x is equal to 2. Then, for the second equation, in the event that the inside of the absolute value is negative, I have a minus 2x plus 3 is equal to 7. So I divide through by the negative, and I get 2x plus 3 is equal to negative 7. And then I solve accordingly. So I subtract 3 from both sides, and I have 2x is equal to negative 10. And when I divide by 2, I see that x is equal to negative 5. So when I go to check this, I plug in 2 for x. So I have absolute value of 2 times 2 plus 3, which gives me absolute value of 4 plus 3, which is the absolute value of 7, which we know is just 7. So this answer checks out. And then when I plug the second one, I have 2 times minus 5 plus 3, absolute value. So this is the absolute value of negative 10 plus 3, which is absolute value of negative 7, which is also just 7. So this one checks out also. So let's say that I had something like this. If I had x squared minus 3 is equal to 2x. Well, the same thing is going to happen. We have two equations. And so what I'm going to do is I'm going to say x squared minus 3 is equal to 2x for the first one. And so this is going to be of a quadratic type. So I'm going to move the 2x to the other side. And I have x squared minus 2x minus 3 is equal to 0. So this one factors into minus 3 plus 1. And then you set each of the factors equal to 0. So if x minus 3 is equal to 0, and x minus 1 is equal, or x plus 1 is equal to 0. So I have x is equal to 3, x is equal to negative 1. But we're not done yet. I still have to check both of these answers to see if I get a true statement. So if I plug in the 3, I have 3 squared minus 3 is equal to 2 times 3. So to do the math, I have 9 minus 3, which is absolute value of 6, is equal to 6, which is true. So the first answer is a good one. Now let's plug in the second answer. So I have negative 1 squared minus 3 is equal to 2 times negative 1. So negative 1 squared is 1, and 1 minus 3 is negative 2. So I have absolute value of negative 2 is equal to negative 2. Well, we know that this is wrong because absolute value cannot be a negative number. So we know that x is equal to negative 1 is an extraneous solution. And so for the second part of the equation, we have minus x squared minus 3 is equal to 2x. So I have x squared minus 3 is equal to negative 2x when I divide through by negative. And then when I move the 2x over, I end up with x squared plus 2x minus 3 is equal to 0. So this one's factorable. I have an x plus 3 times an x minus 1 is equal to 0. So I set each of the factor pairs equal to 0. And then solve. So I have x is equal to negative 3 and x is equal to 1 to evaluate. So I'm still going to have to check these to see if they work. So if I plug in negative 3 here, I have negative 3 squared minus 3 absolute value is equal to 2 times negative 3. And when I crunch the numbers, negative 3 squared is 9, and 9 minus 3 is 6. So I have absolute value of 6 is equal to negative 6, which we know is not true because absolute value is never negative. So we know that x is equal to negative 3 is an extraneous solution. And then the last one that I'm going to do is positive 1. So I have 1 squared minus 3 is equal to 2 times 1. So 1 squared is 1, and 1 minus 3 is negative 2. So I have absolute value of negative 2 is equal to 2, which we know is a true statement. So the answer, x is equal to 1, is valid also. So the two solutions for this absolute value equation is x is equal to 1 and x is equal to 3. So I have one last example, and let's say that x squared minus 6 is equal to x. So we're still going to have two equations to solve. And the first one is just going to be x squared minus 6 is equal to x. So the first thing that I can do is move the x over to the other side. So I have x squared minus x minus 6 is equal to 0. And this quadratic equation will factor into x minus 3 times x plus 2 is equal to 0. And so when I set each of the factors equal to 0, I have x minus 3 is equal to 0 and x plus 2 is equal to 0. And when I solve for x here, I produce a couple of answers. I have x is equal to 3 and x is equal to negative 2. So I notice that if I plug in negative 2 into the original equation, I have the absolute value of negative 2 squared minus 6 is equal to negative 2. And I know this answer is going to be extraneous because the absolute value cannot be a negative number. And if I plug in x, I'm going to have an absolute value of something is equal to negative 2, which is a contradiction. So if I plug in 3, I have 3 squared minus 6 is equal to 3. So 3 squared is 9, and then 9 minus 6 is 3. So I have the absolute value of 3 is equal to 3, which we know is correct. So the answer, x is equal to 3, is valid. And so the next equation that I have is minus x squared minus 6 is equal to x. So when I divide through by the negative, I end up with x squared minus 6 is equal to negative x. And then I can move the x over to the other side. So I have x squared plus x minus 6 is equal to 0. So this quadratic equation factors also. I have x plus 3 times x minus 2 is equal to 0 this time. And so I set each of the factors equal to 0. So I have x plus 3 is equal to 0 and x minus 2 is equal to 0. And this produces the answers. X is equal to negative 3 and x is equal to 2. So I already know x is equal to negative 3 is going to be wrong based on the same logic that I applied to the negative answer in the first equation. And so let's check x is equal to negative 2. So I have the absolute value of 2 squared minus 6 is equal to 2. 2 squared minus 6 is negative 2. So I have the absolute value of negative 2 is equal to 2, which we know is a true statement. So the answer, x is equal to 2, is valid. So I hope this video was helpful in learning how to solve absolute value equations. I hope you guys learned something from it, and so stay tuned for the next one. Take care, everybody.